So now let's take a look at how the function pointers can help us. And this is like a very simple example. Of course, this example that you'll see doesn't have to be this convoluted, but the idea is that the same version in the real life comes in very handy when we are talking about, real life implementation of file system drivers, some embedded code, event-driven programming, and so on and so forth. Not event-driven programming, but event-driven the implementation of that library, right? So the library that drives events and dispatches events, I'm talking about that. All right, so let's take a look at what we have here. First off, maybe let me go ahead and full screen this. Then let me go ahead and explain what's in here. So we are including now some .h file that is locally available. I have implemented that file, right? And then I also implemented a math underscore library.c, and then we have the main.c. Ignore the a.out, that's not necessary. All right, so what's happening here? We have the main function here, and it is calling a function execute underscore operation with add as some keyword, some sort of a token here, and I'll explain what the token is, followed by 105. And everywhere we are kind of passing 105, right? 100 comma 5. So two of the function parameters are 100 and 5 separately. And first parameter here is some, you know, macro essentially, add, subtract, multiply, divide. And my hope is the way this is designed, the way this math library is designed, which is my implementation, is that the same function, depending on the zeroth parameter, will do different mathematical operation, right? And let me then go ahead and explain what that library implementation looks like. So in the header file, first off, uh, notice that we have this function prototype which says that the first parameter is an operation, second one is a, third one is b. Operation will be performed on a and b. Right? And we have some hash defines here, which is 0, 1, 2, 3. Right? Okay. Now let me go ahead and open up the implementation of the library, which is like too much code and you can browse through the code, but it makes sense. So first off, I have four functions here. I have the add function, the subtract function, the multiply function, and the divide function. Right? Each one of them takes x and y as inputs, and they just simply print the operation. Here you see addition, here subtraction, multiplication, and division. Right? And so after this, from this line onwards, line number 19, and let me scroll the code up. So after line number 19, we have some interesting stuff. So notice the type def here, which says the function pointer when dereferenced will not return anything. So it will point to function that returns nothing, right? And then it shall be called func underscore t, takes in a and b as parameters, so two parameters. In the previous examples, we did not have this, but if we have that, if we name the variable, that's all right too, not a problem. And notice we have type def, which means this is a new type now, right? And instantly on the next line, what we do is we say, hey, func t is the type, and I want an array of that type, and we call that array func_lib. So func_lib essentially is an array somewhere in the memory, which will now have addresses, which will have addresses here. The elements, so to speak, are addresses, and those addresses are pointing to functions, and the functions have the signature or prototype of this nature. And um, if you see, each one of them is void type, takes in two integers, right? And so what we are doing is we are now assigning the elements values. So inside the array, we have address of add. Let me put this address of add, address of sub, address of mul, and address of div, right? And then depending on what operation I give, which is okay, which is kind of right here, depending on which address I give, it in it we kind of dereference. First off, we reach out to an element of the array and then we dereference that. This is like a very convoluted example, and this is also very close to what we do in real life. We have like array of function pointers. We go into that array, select the function pointer that we want, which is essentially what is happening here. And then what we do is provide the parameters and execute that function call. So let me then go ahead and compile all of this code, and I need to follow some special syntax, which is this time around I also have to kind of provide the library that I have implemented. So a math underscore library dot c along with the main dot c. Let me then go ahead and execute. Everything compiles, and let me go ahead and now execute the program, and you should see that the first invocation here leads to 105, which is 100 plus 5. Second one is subtract, so 95. Multiplication is 500, and div gives us 20, which is 100 divided by 5. And with this, hopefully you got like an experience or like a real life example of how function pointers can be used. And in addition, we also covered how you can go ahead and declare like a array of function pointers. With this, pretty much we are done with function pointers.